Welcome to Slight Reliability, the show where we learn SRE and observability 1 week at a time. I'm Stephen Townsend. Welcome back to Slight Reliability. I'm Stephen Townsend, and this is the show where we learn about SRE and observability. That's the one, yeah. 1 or 2 weeks at a time. Today, Paige Cruz is back again, which is awesome because she's one of the most popular guests we've ever had on the show. So how are you going, Paige?
I'm doing pretty good. I've been using my unlimited PTO to attend some fiber festivals, so I'm in my happy place.
What's a fiber festival?
Oh, right. When talking to tech folks, I have got to explain not fiber like networking or internet C cables, but fiber as in what we get off of sheep and cashmere goats and alpaca. That is what I do to get away from all of the bits and bytes and being on Zoom often.
That sounds awesome. Paige is the Senior Developer Advocate at Chronosphere, and today what she wanted to talk about, and something that I've been dabbling in, is sampling of distributed tracing data. Do you sample other data, or is it mostly just traces?
You can sample. I was thinking about this question of when you decide to, say, drop logs from your staging cluster or something like that. You can kind of think of that as sampling, but it does have a very particular semantic meaning within trace data specifically.
I could imagine, let's say profiling becomes mainstream, that would be another use case maybe for sampling, because there's a lot of data. Yeah. Okay, just to get things underway, just for anyone out there who's not super familiar with what distributed tracing is, let's start with that. So what are we talking about when we say distributed tracing?
Yeah, I love starting here because despite tracing being around as a concept for 13 years, we still have many people who have not experienced the joys of troubleshooting with tracing. And so really, our story starts before tracing, back in the time when monoliths ruled. And APM, or Application Performance Monitoring, was the best way to get insights into how that monolith, how the system was behaving, how user requests were managing through whatever framework you were using, and it gave engineers all the visibility they needed. But then the rise of cloud computing, containerization, and breaking up that monolith into microservices meant all of a sudden what was this one big box of an application on a diagram became this huge constellation of interconnected and separate services. So the focus of APM for that one big monolithic box really didn't help engineers understand that entire galaxy of all the microservices. So distributed tracing came to solve that problem, and the trace is essentially tracking the path of an individual request as it ping-pongs through all the multiple services to provide a full picture of what your system is doing to fulfill that top level request. I think I'll leave you with the best pitch for tracing comes from that really famous Uber engineering blog post from back in the day. Quote, distributed tracing made queries like find me requests where the user was logged in, the request took more than 2 seconds, only certain databases were used, and the transaction was held open for more than 500 milliseconds possible, end quote. Like tracing is making the impossible possible, and I can't imagine trying to construct that query from every individual component's point of view.
In a sort of more fluffier context, I sometimes talk about this idea of unknown unknowns and the enormous complexity of the digital age, which I've read about in many books, actually. I think tracing is sort of the perfect way to make sense of that kind of complexity when you have it. Without it, there's always going to be blind spots. There's going to be too much stuff going on to be able to make it observable, essentially. Yeah.
Yeah, and I was really lucky and fortunate that while I started my career as the complexity of cloud and containers and microservices started, I was at a monitoring company working on the tracing product, kind of greenfields there. And so basically from the beginning, I've always had traces to understand my systems. And particularly, I think it's the visualizations that we get from trace data that are so powerful. Not only that waterfall view which if you've used Chrome Dev Tools, it's sort of the network waterfall, very similar concept. Or being able to see what services talk to each other to draw a topology view, sometimes called a service map. It's literally a real-time architecture diagram that you didn't have to beg 5 architects to sketch out and munch together. It's literally the way that your services are connected. So for me, without having that topology view or without being able to see all the work a system does for some top-level user request, I'm not a fan of investigating issues without that visibility.
So that's what tracing is. Mm-hmm. There's lots of data being collected, and every single hop along the way is a span, and they all get sent somewhere, and they get kind of pulled together, and there's metadata associated with it. What's sampling?
So sampling is the process or the methodology for selecting what spans and the traces that those spans are a part of to process, export, and store. It really answers 3 questions for you. What traces should we keep? What traces should we discard? And really the kind of the kernel of both of those questions is what constitutes an interesting trace? We want to sample traces in their entirety. We do not want an incomplete trace that would be like the library handing you a book with the last 2 chapters. You kind of are missing some important context along the way. And so one feature of a particular sampler in OpenTelemetry is called parent-based, where as this request hops from service to service, the spans get the message, hey, should we create and hold this span, or do we not need to do this work and continue on my way? Because incomplete traces are an unfortunate, they're just not something that you want. You want a full, beautiful, rich trace.
So it's about figuring out which traces you want to keep, which ones you want to get rid of, and what constitutes an interesting trace or something that might be valuable to know about.
Yeah.
But sort of at maybe a more detailed level, like what is the value? Why not just keep everything? Or
yes, this is the question. And it is a really important question for practitioners to get used to answering because I will say, taking a small step back, tracing, if you do not have it already, does require investment from a lot of your organization and multiple different stakeholders, from finance to engineering leadership, from SRE and operators to developers. And so this question will come up a lot. Why even sample? Well, if you did not sample at all and you wanted to keep every single trace that resulted from every single request flowing through your systems, on a good day with a healthy service with no outages, you would end up with a ton of 200 OKs or normal healthy traces. Think about health checks, for example. Yeah. If your health check is reporting just fine, why would you need an entire trace to tell you that? So the value of tracing is really for this troubleshooting. And for me, in my opinion, it's being able to compare a normal trace, your 200 OK, happy normal trace, to an abnormal or interesting trace, whether that abnormality or interest is coming from a particular error or even the presence of an error, latency that is suspiciously increased or decreased, or even like an entire service that shows up in one request but not another. So from this perspective, it is kind of wasteful in terms of computational cost and financial cost to store all of these 200 OKs when we really just need a representative sample to be able to do these comparisons. The kind of cost considerations first come from computationally. It is work for our computers to generate, even temporarily store or process, and then send those spans across the wire. That is real cost that you will pay for computationally, in addition to financially, especially if you're sending to an external vendor or something. Those are things that you want to consider at the start of your tracing journey. But cost cutting should not be the primary driver of sampling. What you really want is to give engineers the right amount of data that they need to troubleshoot at the end of the day. And the one last thought is, this is different from like a metric, where if you choose to drop a metric, you are losing that data. You are losing the ability to glean insights for it. But with tracing, if we're only taking, say, I don't know, 5% of the healthy, successful requests were not actually missing data by choosing to not keep most of those requests. The way traces force you to change your kind of paradigms and mental models around the other types we're used to dealing with, like metrics and logs. Traces are just a different animal.
I've heard other people talk about the metrics you generate from traces and how it's just like the real, like you've got all the data there. It's like, well, okay, but there is, some risk
Yes,
of
and that is a really interesting point of deriving metrics from traces, because unless you're keeping all of your traces, which most people are not for most situations, the metrics that you're getting from those traces are not representative of every single request that has gone through. And so you really need to think carefully when you're choosing your sampling strategy and then choosing to generate metrics from traces, like, say, that Uber example, transactions that are more than 500 milliseconds that touch these two databases. If you're choosing to sample, depending on your strategy, your engineers should keep in mind that they may not be able to do the typical metrics aggregations, or they may not be getting the full picture from that. It's not a dig on trace-derived metrics. I actually really love them. I think it's a lot simpler to do a metric off of a trace than to construct the equivalent multi-composite raw metric query from the raw metric sources. But it is why I wanted to talk about sampling, because there's just a few wrinkles that it's important to keep in mind for tracing to be successful and useful for your organization.
I think it was Martin Thwaites from Honeycomb who said that there is, depending on your tooling, on your approach, you can get trace-based metrics for every single trace, even though, because it like calculates the metrics before it does the
discard decision. Yes, I've worked in systems like that, and to be honest, I did not get a good peek at what that was costing us computationally, or even to temporarily store. And the good news is these sampling algorithms are only getting better and better. My undergrad is not in CS, it's in mechanical engineering and business. But even I can read through some of these academic papers from CS students, and I'm getting really excited about even their kind of first brushes at more sophisticated sampling strategies. So the information we're giving you today is really a point in time. The space is still very much evolving, and the experience is only getting better, both for the customers and then for you as practitioners.
I think one of the core things we wanted to talk about today is that, I've heard about, and I know you've heard about, there's these two different kinds of sampling that you can do. There's head-based sampling and tail-based sampling. And maybe there's other kinds too I don't know about. But what is head-based and tail-based, and how are they different?
This is a great question. I will start with no sampling, and then we'll back into head versus tail. So no sampling is you're keeping everything. You're paying for it. You get all of the data at the most granular fidelity. And this is how a lot of us get started, kind of just turning on that fire hose. Is not sampling a valid option? Yes, of course. It depends. That is the answer to all technology questions. Not sampling is valid when you're targeting and scoping, particularly for really low throughput endpoints that might get lost in the noise of sampling. If a service is only called, once every couple of hours, that trace may not be in the original sampling decision. So you may want to say, keep everything that comes from this service and endpoint.
I was just wondering, can you configure, say, the OpenTelemetry collector, which is what I've been using to try sampling, to say, don't start sampling until I reach a certain transactional throughput, then start doing sampling? Can you do that?
Oh, interesting. I think you could configure that. I know at least there's a functionality to wait to start collecting. I imagine with how open the collector is, if you can dream it up and code it, that it can be your reality for sampling. That sophisticated sort of either dynamic, or we call it dynamic, adaptive, or retroactive, that is where the puck is moving. There is a lot of exciting activity for not having static rules that require redeploys of your collectors or your services. So yes, I think you're thinking like future tracing, or that
Yeah.
may be the reality today. I'll have to check the docs.
Okay. Yeah. I was thinking about, say, the use case of you want to deploy exactly the same tracing to your production and pre-production and testing and development environments, but you know the throughput in those other environments is so low, you just want to capture all the tracing because it's just use. There's no harm in doing that sort of thing. Yeah.
Yeah,
I know.
I think that I think the big takeaway when it comes to sampling is that odds are a blanket approach for sampling strategies for all your services and all your endpoints is not going to give you the best ROI for tracing. The best you can do is to target for those high impact cases, or maybe you're just rolling out new code and you probably want to capture most of those traces for 5 minutes, say, so you've got a nice window of comparison. So the we'll talk first in the more kind of conceptual view of how head-based and tail-based got started, but
Yeah.
know that you'll get the most value by not doing a blanket one-size-fits-all policy for sampling. We've struggled a lot as an industry to get tracing adopted mainstream. Most of the engineers and operators I've worked with are total aces when it comes to metrics and logs and querying and analyzing that. And tracing continues to be this power user tool, and I find it really unfortunate. And so I think one of the struggles with getting tracing adopted at your company is this question of managing the scale and the volume of the spans and the traces. So if we can get everybody comfortable with the menu of sampling options, I'm hoping this means more people are interested in exploring trace data and actually finding it valuable instead of a bunch of 200 OK identical traces.
Mm.
So with that, head-based sampling, we'll start there, means making that decision whether or not you want to keep the entire trace and at the beginning. So we kind of use trace in spans. What we mean is, like you said at the top, spans are emitted from every service at every hop of a request. A trace is all of those spans assembled together in correct timeline temporal ordering. And so when you're making a decision whether or not to keep an entire trace at the beginning, you don't actually have the whole trace to make that decision on. You just have that top level request, that first span. We call that the root span, like a tree. And this, you can relate this to a policy like randomly sample 1% of all traces, or of all the requests you see, decide to create traces and create all of those spans for that trace at the very beginning. This is done like probabilistically, essentially rolling a dice, or you can go as fine-grained as like rate limiting by a particular attribute. So head-based sampling maybe doesn't sound like the best when you put it in that light. You don't have a lot of decision when you're making this call. When would you want to use head-based? Really great for high throughput endpoints. To be honest, you will likely get a representative sample if you just have a lot of data points to choose from. It's great because you're saving all of that computation of generating the spans, sending the spans to a collector, sending that trace onto a vendor. You're saving a lot of money and time along the way. But you don't get to do smart things like, say, sample all traces that are errors. We talked about interesting traces, high latency, errors, maybe particular attributes. You really don't have that data to make a decision with head-based sampling. Is this something that you've played around with the OpenTelemetry collector?
Yeah, in fact, the head-based sampling is the only thing that I've tried so far. Tail-based sampling is my next thing, which I was going to have a look at tomorrow, with it, hopefully if I've got time. But yeah, the only thing I implemented was literally just keep 5% of my traces, please. And
Okay.
that was it. That was it. I didn't go any further than that. But I just wanted to prove out that I could, get it working.
Yeah, it's a natural place to get started, I think, especially because most tools have this like batteries included, ready to go. It is a little bit more straightforward to implement. And I will say, in defense of head-based sampling, it does not need to be this static, like, 10% keep 10% of traces. Well, what happens if you get a big unusual spike in traffic, or someone decides to accidentally turn on a bunch of metadata on spans, blowing up the overall size of your trace. This idea of adaptive sampling, instead of just rolling the dice fresh every single time to decide whether or not to keep that trace, adaptive head-based sampling means recalculating that sampling probability continually to ensure that the volume of traces we're keeping actually matches the target sample rate like per second. So while on its face, head-based sampling looks kind of naive, you actually can get more sophisticated with it and increase the confidence that the data you're keeping is going to be useful.
So any information which is attached to that root span, that you can do decisions based on that, right? So so if you had some sort of label that said team or like service, or let's say team, for example, team, and then a particular team name, and you're like, we want to sample this team's traces this much, and this other team a different amount, and you could do that?
Yeah, I think you would be able to. I think that might be a little bit of custom work. I'll have to double check the docs, but if you can inspect what's on that span, whether it's team, a very popular combination is service and endpoint. You typically, as an organization, know where your hot paths are, or the revenue generating requests, like say checkout for e-commerce. You probably want to have, if you have a static tracing budget or observability budget, you probably want to make sure you're spending most of that on the areas that are most critical to your business. And that's really where that targeting comes in, not doing that blanket policy, but really it always starts with a conversation. What is important to us? What should we be measuring? What is difficult for us to investigate today? That's where you really want to target either sampling more or even adding additional instrumentation like customer tier tag. If you want diamond tier customers to always be able to get the best service, you maybe want to sample more of their traces versus the free tier.
Yeah. So that's head-based sampling. It makes sense to me. What about tail-based? What's that about?
So tail-based is the most, I think, interesting and the most difficult to make cost-effective, both computationally and financially. But in a nutshell, tail-based sampling means making the decision whether or not to keep and store durably a trace after the entire top-line request is fulfilled, all of the spans have been generated. It's very important that all of those spans get sent to the same instance of a collector. At scale, you will be running a whole fleet of collectors. That is a bit more work for your SREs and operators to set up in a scalable manner. But what is really nice about tail-based sampling is now you can say, keep all of the traces that have errors and or high latency in addition to 5% of the successful traces. So you really get a lot of control on tailoring what an interesting trace means for you and your organization or a particular service or endpoint. The downside with tail-based sampling, of course, is one, it is higher overhead on your system to generate, and even temporarily storing these spans at a certain throughput can lead to like ooming or like just using a bunch of CPU cycles and increasing the latency of requests. You really never want your observability libraries and agents to have an adverse performance hit. And I would be really curious, Stephen, how you think about this as a performance engineer, that balance of visibility and awesome, getting to keep all the traces we find interesting versus affecting ultimately the customer experience.
I think, once again, it depends on context and how critical something is, and just because if there's a serious issue and lots of customers are affected, then if you're sampling, it's not going to make a big difference anyway. The thing you're going to miss out on if there's a particular customer maybe who's having a weird issue with their particular account or setup, or if this one-off weird things happens which causes significant damage. Maybe someone has access to someone else's another customer's personal information, or and you wanted to investigate it, and if the sampling might mean you can't get access to that trace. But it's about probability and risk, right? Like, you don't want to like invest in this thing which may possibly happen. A 1 in 10 trillion chance. You know what I mean? Like you don't want to invest a
Totally.
bunch of time and money in that. It's a balance.
Yeah. It's something I used to think about a lot when I worked at a company that had proprietary agents. We talked a lot about how we really should not be affecting application performance, but also you don't get metrics, logs, and traces for free. There is that balance of what's the amount of work that's acceptable that isn't affecting experience, but also still allowing our engineers who are on call. There is a huge human cost to keeping these distributed systems up and running. How do we empower them and give them the data they need uh, to effectively investigate? And
Mm.
traces are my answer to that.
I remember back in the day, the APM vendors, we would often implement them, and there'd be some sort of statement like, "This will not have more than like a 2 or 3 or 5% CPU overhead on each sort of server or VM that you run this on," and
Wow.
we would have to performance test to validate that fact. I don't think we ever actually found any issues.
I like
Yeah.
that kind of contract. And I think that's what's interesting about this sampling algorithm is there are just so many choices that you have between head-based, tail-based, and the various implementations of both of those concepts. Two, like we've talked about with the open telemetry collector, you can now write your own algorithms, rules, not protocols. You can write your own sampling algorithms and rules and policies, so keeping track of the performance overhead of your sampling algorithm is something I would recommend people keep an eye on. I guess what you want to avoid at the end of the day is this panic moment of we're either affecting customer experience or our observability bill is so high that now we want you to uninstrument or to take out some of this data because it's costing so much. With all of the interesting financial decisions getting made and private equity buyouts and layoffs, the place I don't want organizations to cut willy-nilly is the visibility engineers need, the few engineers that you've got left, what they need to do their job. So it's why I wanted to talk about trace sampling, because knowing all the options that you have and knowing what would work best for your system and when means that you can navigate these changes a lot more confidently, because it's not a set it, forget it, or a one size fits all. You actually have many, many options for making this work.
I had some particular use cases around tracing beyond the norm that I wanted to talk about. But before that, I have been implementing tracing with the OpenTelemetry collector in the collector and the configuration of the collector. There are other ways you can do it though, right? Can you do it like within your instrumentation, like at a code level from each app that you're doing? Or am I imagining that?
For KubeCon, I'm running a tracing instrumentation workshop. And there are some times that I'm just hacking on the app that I do not want to see all the logs about you're not sending hotel metrics, you're not sending hotel spans. I don't want that. I just need some really quick iterations, and I'm not going to be looking at trace data. So I do believe you can configure per service or per instrumentation library, like an always on, an always off, or other different configurations. That is nice when working locally. It is nice to be able to, per environment, have different configuration for a particular service. However, when we think about production, the trade-off that you make by configuring that in the service itself is when you want to change perhaps your sampling strategy or even the percentage that you're sampling from 1% to 10%, you will likely be requiring a redeploy of that service with the updated config, which, depending on your org, can or cannot be a big deal to do. So the other option is configuring that externally in the open telemetry collectors, for example. That is one place that you can go to make all of the sampling configuration changes you want. And if you're doing that, it's a good idea to make sure your ops team is really up and comfortable with how the fleet of collectors interacts and operates, because you may or may not need to redeploy those to pick up those changes. So it's kind of about where you're most comfortable making those changes and what's most efficient in your particular org.
You mentioned before about how you have to send, if you want to build a trace, you need to send spans to the same instance. Can that instance be like a whole set of containers, say, running the collector, which are the same? Can they have the same state? Like a shared state across them, or does it have to be an actual individual container or server?
I believe it needs to be like, you need to maybe have a load balancer in front of your fleet of collectors to make sure it gets sent to the same place.
Okay, like sticky session sort of thing.
Yeah, or some sort of, I forget how we've done it at past companies, but it is really important that, because it's that collector that needs to decide whether or not to send all of those spans onto your vendor or self-hosted solution. If you would have to coordinate among multiple collectors who are also still dealing with ingesting and processing data, that becomes a lot more complicated of operations. So I think it's best for everyone that you send it, you figure out how you're going to send it to the same instance.
Okay. Hopefully there's some documentation somewhere that could suggest some load balancers and config that could do that, hopefully.
Yeah. And while OpenTelemetry is a new project for some, there have been people using this in production for multiple years, and especially learning the ins and outs of scaling your fleet of collectors. So this is not new ground that you need to pioneer or trod through. There should be a lot of great resources out there from conference talks or blog posts, or even if you're lucky, Kubernetes operator or some Helm charts or whatever you use at your org to get started with a scalable set of collectors out of the box.
The most common use case would be you've got customers using a system, there's a whole bunch of transactions going on, you're capturing them, you're keeping some, you're getting rid of others. But there are some other sort of use cases. And one that you mentioned, I think, was around, which I think is awesome, is CI/CD and tracing that. So that sounds, can you tell us a little bit more about that? Because that sounds pretty cool.
I love non-production incident tracing use cases because I love showing people the power of telemetry data before production. It doesn't always have to be this scary incident that you're paged for that you go to your observability tools. You should be in and out of there all the time. So I've at a couple organizations set up or migrated CI/CD systems. And it was a few years ago that, DORA metrics are still really valid and popular, but it was when they had kind of first burst upon the scene. And I thought, I wonder if I could not only use distributed tracing for create a trace from a single pipeline that executes, but if I could also use that data to power DORA metrics about the change failure rate, the number and frequency of deploys. Typically, one pipeline's owned by one team or it's attached to one particular service. And so it was this really interesting way to get organizational data really about the software lifecycle. And at the time, the vendors were not all up on DORA. So it was something I was going to have to manually instrument. So I thought, okay, for the systems I'm used to with CI/CD, your pipeline, each step in a pipeline runs in its own container. And yes, sometimes you're parallelizing a bunch of your tests, so things run efficiently. Sometimes it's sequential, but this is really the perfect model for a trace, with the caveat, I have heard of some people who have very long running pipelines. And one limitation of tracing today is like if you're doing the tail-based sampling or just in general to assemble a trace, you've got to hold all of the spans that have led up to that trace in memory until that final operation is completed. So for the systems I've worked in, our pipelines would run sub 15 minutes. I think that's like the most extreme case I saw. And so for us, tracing was a great fit for a use case because it allowed me as the SRE who had to support our users. I was on, support duty if someone had questions about a pipeline or they thought our infrastructure was, wonky and they couldn't figure out if it was a change they made to the pipeline or what. I really liked the ability to say, is there an issue with the overall CI/CD system? That is, are there multiple distinct pipelines from different services that are failing in the same 30-minute window? Or is it just one team and one pipeline that's having an issue, and that perhaps I maybe think it might be a change that they've introduced? As an SRE, it's kind of indispensable to have that bird's eye view of the system, because I didn't know all of the app teams and I didn't know everything about every individual service that was out there. And at least at the time, CI/CD vendors were very set up for application developers. It was all about your service, your pipeline. I could never get the aggregate data that I wanted, and it really frustrated me, which is why I instrumented to fill that visibility gap.
Cool.
Yeah, there's one other, I think as a performance engineer, what you would appreciate is the pipeline optimization that you can do by saying, well, which step in this particular pipeline is taking the longest? And for me, most of the time it was a Docker build, and we had kind of shoved containerization. It felt like ops kind of shoved containers onto the devs. And there is an art to an efficient Docker file. There are things you can do to optimize how long it takes to build that image. And so this was always a good key for me to say, well, devs are complaining about how long the pipeline takes. Well, where's the source of what's causing it to take the longest, and go from there. Yeah, I think to wrap up the thought, the power of trace data for me is getting both the bird's eye view of traces and aggregate down to the single trace waterfall. What work is done in our system to fulfill this request, and being able to use that data to advocate for organizational changes I wanted. Because engineering leadership will maybe smile and nod if a bunch of engineers complain about how long their pipelines take. But if you come to them with data and say, on average, we spend 40 developer hours a week just waiting for our changes to hit the staging, let alone production, that means our ability to hotfix is, this many hours of a window long. When you talk in terms of data to leadership, that is where I've seen the most success changing practices or getting initiatives off the ground and solving the real developer pain points. Not that the feelings aren't valid, but when you pair them with facts, you get a lot further.
And it seems it's a challenging thing to get quantitative, whatever, however you say it, quantitative data that really tells a story and isn't sort of fudged, that's awesome. I like that. The other use case from my past is performance testing, where you would be running, you would want to run a test for, say, an hour, and you might make 1 million requests. And I know that's a fair amount of data. You want to keep everything, at least for a little while, because you will look at the results later and you might see particular patterns from the logs or your test results and go, I want to investigate. I can hover over this thing, see what the trace ID or the header is, whatever it's called, correlation ID. I want to go and I want to see exactly what happened for that request. Why did it take 5 minutes?
Oh, interesting. So in the case of a performance test, if I think back to the answer of why sample and why sample traces, because traces are this new distinct type of telemetry where a bunch of 200 OKs, you don't need to keep all of them, or like the health checks say. What is the case for performance testing to keep all of the traces, knowing that if you've got a bulk of identical traces with the same outcome, what is the value in keeping those for a time box performance test?
It's more just, I've been on that. That's the person doing the analysis of some results. And I've got a scatter plot in front of me of like 100,000 or 1 million points of data. And I'm looking at certain things and I can see unusual patterns. And I'm like, wonder what happened there. And like, I don't want to be limited and say, oh, actually, no, we don't have that particular trace.
We didn't keep the trace for that. Okay.
Exactly. Even if it was a temporarily keep everything, or if it was I want to send a special header that says, keep all of these samples, please. Or even if I only keep them for half a day or a day.
Oh, interesting. Yeah. Well, aging them out of storage quicker. So for performance testing, how do you fund that? Do you have to tell leadership this is going to cost us, $10,000 an hour that we run? Or do the organizations that are serious about perf engineering, they already factor that into the budget, and it's an open checkbook?
I've never really talked about it like that before. I've been on the side of a consultant, and I'd be thinking about the hours of effort that I'm spending on this. The
Sure.
actual performance testing infrastructure and the cost of running things usually wasn't really considered. The only time it was considered is when we were building
Yeah.
some stuff on a Salesforce platform, and there was a cost for every account that we created. And
Oh,
so
okay.
that really, we said basically we had to decide we can't do this because we're going to have to create thousands and thousands of these production accounts, which cost money. So yeah.
That's wild. I think because tracing, if you don't sample, can be such a financially expensive thing to do, I think that's why this conversation's so timely, because a lot of orgs look at their cloud spend. They look at what they're spending on infrastructure. That's where FinOps came from. But observability continues to be this mysterious bill that sometimes goes up and causes, like an internal incident where all hands have to be on deck to fix it. And at least with trace data, if we're ever going to make tracing super wide stream successful, I think keeping in mind the financial cost of different strategies is our ticket to getting adoption.
Yeah.
There's a lot of barriers to tracing adoption. That's why I talk about all the things that I love and the power that it brings, because we've still, I think, got to win hearts and minds.
We're running out of time, but I did want to know before we go,
yes,
some practical tips or sort of advice you could give people who are beginning their journey. Maybe there's someone out there and they've got head tracing implemented for a little while without any sampling, and that's going okay, but maybe their service is growing and their product's getting popular. There's a lot of volume now, and they're thinking about needing to implement sampling. Any advice?
Yeah, I think, of course, historical performance never predicts future outcomes, whatever the finance people say. However, thinking through scenarios for whatever seasonality that your business is in, maybe it's hospitality and around the holidays you get a lot of activity, or it's, Cyber Monday or whatever for your org, the peaks and valleys that there are, look back historically to see what that request volume was. Maybe do a little bit of light napkin math to compare what visibility and cost you would get by choosing head-based or tail-based, or for the checkout endpoint on the order service sampling at 50% or something like that. If you can do a little bit of napkin math, even though as engineers we want the precision, we want the accuracy, the napkin math can help you weigh the pros and cons of going with each strategy. It's something you can present to others and get their feedback. I think you need multiple perspectives in order to come to what the right approach is for you. So that's my main advice, is really weigh for the certain situations that hit your business and your affect throughput mostly, what each type of strategy how that would play out for you.
I guess that kind of means you kind of need to know at some level how much your tracing is cost you, or each trace is going to cost you, like a cost per trace per day or per, I don't know. Is that
I would
possible?
say if you have an observability vendor, they should be willing to do the legwork to come help you come up with some estimates of that. And, don't hold them to every single penny, but really the broad strokes of how this would affect things. Because when I talk about multiple stakeholders needing to really grok what the buffet of options for sampling is, it's really for developers, because when they're analyzing trace data or looking at span or trace data in aggregate, they need to understand, is this 100% of everything? Or is this only 10% of requests that went through our system? That's something they've got to keep in mind when they're doing their analysis. SRE and operators need to understand the sampling options available, because they will be implementing and configuring that most likely. And they need to be really comfortable making those changes and understanding how that will affect the system. Like if you choose tail-based sampling, you will probably need very good scaling strategy that's automatic for your collectors. And the last person is, of course, leadership, whether that's within engineering or finance. They need to understand how the sampling choice you make will affect the financial cost at the end of the day. And maybe not down to dollars and pennies, but the broad strokes of this would cost 20% more to do tail-based versus head-based. Those sorts of napkin math comparisons really help all parts of the business get their heads around this new concept.
Thank you so much, Paige, for coming back on the show for a third time. You're the only person who's been a guest 3 times, I think, on the show.
I love it. Thanks for having me and letting me talk tracing. If this is something you're experimenting with or want help, come join us in the CNCF Slack Open Telemetry. I believe we've also got a channel for the collector. You don't need to trod this path alone. Please join the community and we can share stories and strategies.
And to everyone else, thank you so much for tuning in once again to Site Reliability. Hope you have a wonderful week and the Paige stays calm. See you next time.